All right. Okay. Good afternoon, everyone, or good morning to our professor from France, Dimitri. It's fascinating that across time zones also we're able to meet with this technology. This is exactly the vision that NPTEL had when they started the whole idea of remote learning. The need was that they felt that good quality content in classrooms should be available to people all across the globe, no matter where they are, no matter what time zone they are in. So, sort of serving that purpose in the last more than a decade at least, I think. So again, it's great to be back with all of you folks, and I have Professor Dimitri, who is. These live sessions are meant to answer your queries from the last week's module that is out, the videos that are out. Some content is easier to comprehend for some of you, and some of them are a bit challenging. So we want to see what is it that worked for you, what is it that you found challenging, and you can ask us questions, give us your thoughts, feelings, and we would be happy to take that feedback and answer and respond wherever possible. Of course, if not for these live sessions, we are also responsive on the forums. We will definitely be looking at them. Even if we don't answer them sometimes on the forums itself, we will definitely take them in the live sessions. Okay. So this is the last live session before we head on to the exams. The exam just before the exams, or maybe a couple of weeks before the exams, we plan to have one live sessions to address the butterflies in your stomach before the butterfly. I'm sorry, before the exam. So we'll definitely help you out there. Okay. So good morning, Professor Dimitri. It's great to have you here for answering the questions.
Yeah. Good morning. Good morning and good afternoon, Bala. Thank you very much for having me with you within this live session. And thank you for all the participants of our course for your questions that you submit. It showed to us that you are working, you are interested about the course, and you try to understand really essential things. I also glad to see that our live session recorded in YouTube last week, we saw more than 900 visitors who watched our video, and that we recorded last week. It means you are interested about, and the things that we are doing seems interesting. Today, I'd like to answer in brief the question that we collected between previous session and today's session. And after that, of course, if you have a question, people who are online, synchronous with us, do not hesitate to put your questions. For people who are connected through the Zoom, you can put it into the chat. For people who are connected through YouTube, you can also ask your question. We will be glad to answer them. Well, the first question that I'd like to start with, let me share the screen and let us go one by one with your questions. Okay. Can you see my screen? Is it okay?
Yes, I can.
Okay. So the very first question, this was about understanding of the life cycle of technologies and clock speed for different industries that we tried to share with you within our course. And the question was the following, that some products, just a second, I'd like just to shift it. Yeah, some products in fast-moving consumer goods dominate market for years, how they fit here in the table. And I do like this question, because this question helps us to understand the difference between operational forecast, tactic forecast, and strategic forecast, what we are talking about. right, we have a fast-moving consumer goods, like food on the shelves, or like beverage on the shelves. Looks like they stay a long time. But if, for instance, I look to the evolution of those products, in fact, each of these products, for instance, like bicycle, we have a new version of bicycles every 4 to 6 years. It means if you try to buy today the bicycle which was sold 10 years ago, 15 years ago, you will fail. There are no such products on the shelf anymore. And so that's why this table, it represents empirical results of empirical research, evidence from field, if you like, how often new products appear and how often the process which are behind of the products, they are re-engineered, and how often the new organization appear behind of the product and the processes. The new organization, this is a new companies, or this is a reorganization of existing company. And why this is interesting to see, even for the products like yogurt or like, products from agriculture, we can see that they are also changing with a certain speed, with a certain clock speed. And in different industry, what is useful for forecasting, to know what is this clock speed, because it helps us to arrange meaningfully what is a horizon for the prediction that we are interested to do. Because if, for instance, you are predicting changes in technologies for semiconductors, and if you say, I would like to know what will happen in 6 years, this is a really very long period for semiconductors, because in this industry, the new product appear every 2 years, 1 or 2 years. But if you ask, for instance, for the production of steel, what will happen in 6 years, this is too short for prediction, because the new product in the steel industry appear every 20, 40 years. So this was the main meaning of this table. So even it looks like that fast-moving consumer goods, they are staying on the shelf long time, they are changing. They are changing within this time when they stay long. Even, the product like in the famous network of fast food restaurant McDonald's, okay, they are changing. If you just look behind, and if you just try to recall what was sold in McDonald's 10 years ago and compare with what kind of things you can find in McDonald's today, you will see the differences. So, in order to complete the answering this question, I'd like just to make kind of clear about definition, what is a life cycle and what is evolution. The life cycle, this is a change of a distinct organism or distinct system if it is a change of product within one generation, from birth to death, or to disposal. For instance, you started to produce certain product, and without changes, you produce this product, okay? You produce the same model of bicycle, okay, several years. And we claim, according to the research, that you will produce it not more than 6 years. Within the 6 years, you will change the model, and within 10 years, you will change even the process. How do you make a frame? How do you make wheels? How do you attach rubber and other things? Okay. When evolution, this is a process of gradual change over many generations. It means you produced one kind of bicycle 6 years after that. You started to produce another product. After that, you started to produce, and within a time, they are changing. For instance, fast-moving consumer goods, they can be changed not visible way, like you have a longer time of keeping them on the shelf, for instance, longer expire time. Even you have the same product, essentially. You have the same product, you have the same kind of, cookies, but they are produced different way, or they have some new properties that they were not in the previous generation. So this is evolution. This is a process of gradual change over many generations. This is a one generation life cycle and many generation evolution. What we are talking about in body of this course, we are talking about how to predict changes, evolutionary changes. Which characteristic will change for the next generation? This is essentially the core message of our course. Okay, this was my trial to answer the very first question. So, Bala, do you have something to add?
No, I think this is for me one of the biggest aha moments with respect to this course was to come across this clock speed when you introduced the concept to me quite a while back. For me, the fact that you can have a product, process, and the organization evolving at various speeds itself by just we always assume that yes, product and customers. So we normally talk about these two things: voice of customer, voice of product. This is what we look at in the when we look at trends of evolution, we talk about voice of the product and voice of the customer. We go and find out and all that. But to me, the fact that there is a organization also evolves, and that also varies across industries. This itself was self. Started reflecting on what all organizations have worked with, how were they, in what product were they in. So I think it's very difficult to empirically predict what it's going to be. That's why you can see the ranges there. So that's what I would highlight, that it's going to be very unique for your particular organization, particular industry, particular process, particular product or service that you're launching. So that's the only caveat that I wanted to add. You can't just take that number and say, okay, my organization fits in the 4 to 6 years and 2 to 3. Actually, it may be different. You may have to examine it in that much more detail. That's the only thing I wanted to add. Thanks. Thank you so much.
Okay, thank you, Bala, for this precision. Meanwhile, I found some comment or question in the chart about technology function. For instance, the technology function for the bicycle. Okay, let me go back to my slide, and if you are talking about bicycle, okay, and if you look to this system, what does it change? Okay, first of all, because the function, as we gave you the definition of the function, this is we change input into the output. Okay, what bicycle as a technical system is changing? It's changed the position of driver or passenger or passengers. Okay, they were in one position and they arrive at the end of function, they arrive in another position. So they move loads and they move people. Okay, this is a function of a system. And this function, it is something that very profound, because within the evolution, it changed not so much. And in fact, the function can be performed by many different ways. It can be performed, for instance, by bicycle. It can be performed by motorbike. It can be performed just on foot. We can change position. Or it can be performed by a car, by train, by airplane. It depends on distance and so on. The distance, this is a parameters. This is a characteristics of function. But function is the same. Within the life cycle, we don't change the way, how do we perform it. Within evolution, we change the way we perform towards improving the efficiency ratio. It means, okay, the new bike, what is the difference between new bicycle for this function, moving people and goods from one position to another one, in comparing with previous one 6 years ago? This bike can be lighter, okay? It means it needs less power to move. It can be added, for instance, electric batteries in order to provide some aid when it goes uphill, or recuperate this, generate some electricity when it goes down. But this is essentially the same function, the same way of doing this function. Okay, this is a bicycle, it's not motorbike. But within evolution, it changes property. And the idea of technology forecast is to be able to predict, for instance, in 6 years, starting from now, what will be the new features of the bicycle that will allow us to take strategic decision to which technology to invest, which kind of design to promote, in order to be prepared for the new generation better than our competitors. Okay, this is the main idea. This is the main idea of these numbers, which are purely empirical one. They are collected from the field, and they can be used as an indicator how long it will take. Because there are something which is quite difficult to see at the beginning from logical point of view, like airline companies. Okay, the new product every 5 to 7 years, when the process is not changing last 25 years, when companies appear less than every 5 years. And we can see that low-cost companies, they pop up for a couple of years, and after that they disappear. And this is very, very true what happens. Even the service by itself is not changing, and the process, how it is organized, is not changing. Once again, this table is to help you to choose properly the time horizon for your strategic forecast. Not be just arbitrary what will happen in 10 years, because for different industry, the 10 years is extremely different evolutionary time, because our system, different system, they have a different life cycle. So this was my trial to cover the first question and the question that I found in a chart. And the second question is once again about clock speed, but a bit from another point of view. This
Dimitri, may I add to the previous one?
Sure. Yeah, please do it. Please.
Yeah. So for the bicycle one, I think in the video we have an example, a couple of examples around the same topic of evolution. One of the topics one of the products we took was mosquito repellent or mosquito to deal with mosquitoes. Let me put it that way. Okay, so that was one, and the second one was, if I remember right, it was we had one more as well. The batter, the pancake batter that we used as an example for evolution. Okay, so if you just walk through this video one more time and see where the function is and how it actually changes. So for me, when you look closely, the bicycle itself, we can look at it as a purely technical system of conversion of energy, right? So this is the manual sort of energy. The person who's putting in the energy converts it into a kinetic energy, making this person move forward. So we can look at it from a purely technical perspective and look at it only that, or zoom out and, like what Professor Dimitri pointed out, it could be a means to get you from A to B, right? So place A to place B, how do you get yourself from A to B? Or, even zoom out further and say, why do you have to be at place B? Because you have some work there, or you have to show up for a meeting. Okay, so to be present at point B, not to move, but to be present at point B, right? So in fact, I remember that Cisco came up with a very nice solution called Telepresence. It was extremely expensive early on, but then it made a lot of sense because when this was in 2008, I remember just after the whole there was a huge stock market crash and a financial crisis. The whole world was going up in arms because lots of funding cuts on travel and all that. But Cisco actually came out, with their solution. They had already set up the base. They installed in many places, but people saw immediately the need for that because you can't travel. Even the last 2 years, this has become prominent, right? In all the solutions that you see, it is not a question of the function does it now becomes not to travel from A to B, but how do I show up at B, right? So how do we put ourselves in this place B? So that was a solution that came up now, and more so than ever. In the last 2 years, we've been using this solution. Zoom has been around for 10 years, but it came into prominence in the last 2 years, right? So that tells you that when things start, when we are focusing on a particular function, a certain set of solutions sort of become prominent. But when you move into another set of function definition, you can see other solutions also become prominent. So that was my sort of trial to add this. I thought it was the level at which we're looking at, and we use system operator a lot, and Professor Dimitri did cover this in the course. I think it's in the week 4 or week 3. Just take a look at that. That's mind-blowing stuff also. It'll open up your mind. Yeah, thank you so much, Professor Dimitri.
Yeah, thank you, Bala. Everything starts with a function. We agree with that, because if we don't see the function, we don't see evolution. We are blind with the structure of the system. We have a raised hand. Please open your mic and pose your comment or your question. This is a Rishikesh. Yes, please.
So I only asked the question. So I'll tell you, Professor, why I have this confusion. So in the exercise for week 2, there is a question, right? It's saying ki, what is the working definition of for a function as suggested in our course, right? So the answer that was accepted, I mean, the accepted answer which is posted here, it's saying it is a process that transforms energy of resources from one state to another to satisfy need. Whereas it's like my personal opinion, I feel a more appropriate answer should be, it is a specific process, action, or task that a system is able to perform. And I'll tell you like why I feel so. It's because what about software products? Like when I'm typically using it, it doesn't necessarily transform and energy. With bicycle, I completely agree. I mean, there's a kinetic and potential energy, that concept comes in. Or there are a lot of other products also where it might not be transforming an energy. I mean, obviously energy is, required for everything. If I'm coding, I'm pressing the keys, that is use of energy. But the software that I built out of this process, I don't think that necessarily, in a way transforms anything. So
yes, it is. Yeah. Yes, it is. And it is so ubiquitous for us that we even don't care about. This is electricity that we need to use in order to operate any kind of software, because the software, this is just the command to the hardware, what has to be done. And today, just to give you an example, today by watching video, online video, today more than 10% of CO2 emitted. This is just due to the fact of growing watching the video. You see, but as soon as it is so ubiquitous, we forget about energy, because any transformation, when we define the function, we define what is necessary to be done. And when we start to understand what kind of energy we need, we will arrive, because today we have a third or fourth question within a session which can help us to enclose a bit, describe this issue about energy. Because the energy, this is an essential part of any kind of function. And very often we just improve, we just shift to the next stage of evolution due to reducing energy that we need to use. Please be attentive. Even we are talking about software. The software, this is a particular kind of technical system that we define. Information system, they are interesting one that we can discuss now. I'm delivering the course about forecasting for information and communication system here in EM Strasbourg. And we work with our students how to define clearly what are the expenses to run our information communication system. Thank you very much for your comment, and thank you very much for your question and explanation.
Sure. Thank you. It's great to learn your perspective.
Yeah, I believe our exchange helps us to clarify the subject.
Yes, definitely, Professor. Definitely.
Okay. Now I'd like just to.
Yeah, sorry. One more comment here. I think in addition to what you said, from a legal perspective, when we are filing for a patent is a government assurance of a protection of an idea. Okay, so when it comes to software, they do not consider the idea in the software. Actually, software can only be copyrighted. It cannot be patented. But how do we go around it? So how do we actually patent software then? They actually say that any change that a software brings to a hardware, we are okay with patenting it. We'll cover it with that. So that's even legally, the transformation of something to something has to be explained clearly in your idea. When you are protecting your idea in a software world, you have to explain this function clearly. I mean, there's no two ways to it. So you have to say, you can say that, any keys that I use or any, something that happens in this, how does it manifest itself in a piece of hardware? So software alone, if you try to patent, good luck with that. We have tried it several times, it never works. You have to say what it actually does to a piece of hardware. Then government of India, US, European nations will accept that. Okay, fine, we will accept that it's a clever idea and we'll protect that idea for you. So I just wanted to add, because I've had some personal experiences trying to protect software ideas, and they came back and said, "Oh, software, it doesn't transform anything." But we said it does transform something in the hardware.
Yeah, thank you, Bala, for this.
Thanks a lot.
Comment. Yeah. Now I'd like to shift to the second question about clock speed. And the question is very pragmatically formulated. This is not clear how to calculate the clock speed for any particular business. Okay, this is a good question for me, because in fact, if you have a particular business, what we do usually, we try to find the place of our particular business. Is it in a fast moving industry? Is it a low moving industry, or is it mid-term moving industry? This is a first attempt. But the variable for product, process, and organization, usually we measure by using logistic substitution analysis. In logistic substitution analysis, we are sharing with you some examples in border of in border of week number 4, because in fact, when you define the function, okay, and when you look to the evolution of several technologies, we use, for instance, example of music technologies, like we had a vinyl, after that we had a cassette, after that we had a CD to listen music, and we started to download music after CD and DVD. And today we are downloading even the video, and we are streaming them. Okay, we have a set of technologies, but when you feed this series of technologies with logistic curve, you can obtain very precise result about clock speed in your particular case. Because the table that we suggest for you, this is just to help you to formulate the question about time horizon. Okay, but let us try to make clear what is a product, what is a process, and what is organization clock speed, because they originally in the article where it's from, I took this concept about clock speed. This was published 1996 by Mr. Fine. Okay, and Fine Charles, he also published the book and articles also. He defined it the following way. The product clock speed measured by rate of new product introduction or intervals between new product generation. Okay, it means how often do we have a new TV set, for instance, on the shelf, the new model of TV set onto the shelf. The process clock speed measured by capital equipment obsolescence rate. It means we use, in order to produce our TV set, we use certain technology, certain assembly line, certain machine, and assume that those machines, they are obsolete. Okay, this gives us the clock speed of process. The process clock speed can be also measured when we use the same machine, but we arrange them differently. We use them in different way. Okay, we start to use them different. When organizational clock speed measured by rate of changes in organizational structure. In many cases, this is a life cycle of a company. But for the wise company, smart companies who are practicing forecast, this is a just time of reorganization of their business units, of their structure, what they are focusing on production. They are more focused, for instance, on producing microelectronics, or they are more focusing on producing mechanical, electronical devices, you know. Like, so this is and what is nice, what I found out very interesting and very inspiring for my research about technology forecasting, because these three clock speeds, they are very well aligned with our definition of what is technology. Do you remember? We define the technology as a synergy of a hardware, knowledge to use this hardware to design, produce, and maintain and use this hardware, and legislation and infrastructure, you know. So this is very in the same direction. The story is very in the same direction, because if we change the product, it means for us inevitably we change the process and organization. The more changes on the size of the product we have, the more changes on the process and organizational changes we have to incorporate. When Apple, they introduced their first device for downloaded music, iPod, okay, they changed the process of selling music entirely. The music was sold online through iTunes. This was real invention, not the MP3 player by itself, because we already had a lot of MP3 player before iPod. And they also introduced a lot of organizational changes. Without those organizational changes, this product did not exist. So once again, to come back to the original question, how do we calculate the clock speed for particular business? We look the evolution before, if for instance we are doing business about producing bottle of waters, okay, like this one. We just look how in this business, how often did we sell the new products, and we feed this data with logistic S-curve, and it helps us to make clear logistic substitution model. And on the logistic substitution model, we will see these changes. Please, if the author of the question is around the table, and if you're still in a doubt with your question, do not hesitate to raise your hand or to drop some message into the chat. And we will be back once again to be more pragmatic and practical.
One possible interpretation for me of this question was also that can we somehow, if I enter the type of industry there is, or industry or company or whatever I'm involved in, if I can input that, and can I get pop out these three numbers? So I guess that's sort of is there a model which will help us in trying to get the process, product, and organizational speed numbers? Is there something like that, is I guess the question also. I would think that my own response, of course I'll love your response also on this. My own response to that is this is based on observations and on what we call empirical data. So we take a huge list of all the industries and what all, how have they evolved their products, how have their processes evolved, how fast have their processes evolved, and how as organizations they've actually transformed, which is what Professor Dimitri just commented on, how to actually measure that, right? So if you can get historic data, by all means model that, and you can using the tools that we explain in the course, you can do that for each of those, so for process, for product, and for organization. But if you don't know that, and you just have your industry which is not covered in the list, but you want those three numbers, then this is not a scientific model that will tell us, you put in your name of industry and out comes these three numbers. No, that's not what we mean here. We mean, look, these are products, processes, and organization from all across industries, and look how differently they evolve, and each one to themselves. So there is some commonality among the industry itself, but across industries it varies like hell. So we don't really have a concrete model which can help you there. But if it's your organization, we can certainly look at each of those parameters, get it for you. So that's something that you can do with the elements explained in the course itself. Over to you, Professor Dimitri. Any addition?
Yeah. In fact, I do agree. Thank you very much. Thank you very much, Bala, for this comment. I'd like just to give you some ideas to illustrate what was said just before with something that, okay. Can you see my screen?
Yes.
Okay. Look, this is a fitting of data, time series data about recording media for music industry for United States. Okay, please pay attention. The conclusion that you can build out of this analysis is not relevant 100% for India or for any other country. But what we can learn, we put time series data, and this is a data point for vinyl in terms of market share within a time. And you can see from 1970 to 1990, the market share of vinyl decreased. Okay, when in the same time, the market share of cassette, the green one, this is a cassette, increased. When market share for CD and DVD started to increase in 1990 until 2000 in United States, and somehow in 1995 it was overcome the cassette, and so on. The same story repeated with downloading, and after that this is a streaming. This is a data about streaming with certain forecast, about market share. What we can learn, if the same data, I just look to the media substitution model, like market share, what I can see that the distance between midterm of each technology, it's pretty the same. Okay, I can calculate how many years it is. This is my clock speed. This is my clock speed of this kind of service, recording media for United States. And it helps me to foresee what will happen and when with my streaming music, which is today kind of mainstream, and people usually, when people inside of evolution, growing technology. They don't believe that one day it will be substituted. It was exactly the story about downloading. What can be better than we can download the music? It's difficult to believe, but today we listen in France and in the United States, we are listening to music not by downloading, but by streaming them, because there is infrastructure, it's less expensive and so on and so on. So we can calculate. This was my illustration that with a logistic substitution model, when it is properly applied, okay, we can calculate very precisely and we can support our strategic decision to invest or not to invest in certain technology. Is it okay?
This seems like a fair, yeah. So this is the illustration of what you were saying before. So
yeah,
you have your data.
This was just illustration, yeah. And this is how do we calculate? Because, for instance, this is an upper limit of growth, but we can calculate what is the midterm of growth. For instance, for streaming in the US, this is a 2018, and it will grow, continue to grow. Yeah. This year in the United States, in 2022, in the second part of 2022, the streaming service in US will arrive to the plateau. This is what we can learn from this part of analysis. Well, if there are no comments, I don't see any in a chart. Hello? I don't see. Do we have any hand which is risen? Can
no.
Bala, can you check the question in YouTube, please, if we have something? Because now I'm going to answer the third question.
No, we don't have any questions on
okay.
YouTube.
Okay, thank you. And this is a question about energy that we will connect the point with our discussion at the beginning of our today's live session. This is a doubt about microwave ovens, which are run on electricity. Here, the question is, so can we assume that since microwave oven and induction cooktops also run on electricity, they have the fuel source in diesel or petrol, as electricity generators use these as fuels? Yeah, this is, I do appreciate this question because it shows me that our students, you are really very good analytic mind who are around the table. Today we have a lot of debates and a lot of discussion and a lot of talks about electric cars and how we are going to reduce emission. But if you run electric car, you're running it on the fuel which is you use in order to produce electricity. For instance, if you are in Poland, where most of electricity is produced thanks to the coal, so you are running your car on the coal, not on electricity. And if you calculate the supply chain of electricity to the batteries of your car, you can see that it is less efficient according to the CO2 emission if you use, for instance, the diesel fuel in terms of CO2 and so on and so that. So that's why my answer for this question, yes, when we look to the function and what kind of energy do we use, we need to look carefully. Where is from the energy it comes. And today, we can see that if you look to the diagram about the primary energy sources, which is interesting to see, it is very well aligned with what was predicted 50 years ago. Okay, not 50 years ago, it was predicted in 1987 in border of YAS institution. This is a international think tank which was built on the level of Academy of Science somehow at the end of 70s. And in 1987, they published the report about primary energy sources. with a forecast for coming 50 years. And if you look to these results, it is very interesting to see that we still evolve with our primary energy sources according to what was predicted at those times. So we, especially with electric devices in different countries, we can see that our computers, sometimes they are running on the coal, sometimes they are running on the nuclear power, sometimes they are running on the gas, and sometimes they are running on the petrol. We need always to check when we are talking about function. Now I'm coming back to question about software and the function. We transform energy. We make transformation using energy. Okay. So what kind of energy do we use? And this is a very good way to make analysis in order to predict the changes, because sometimes we just don't understand what is different in our new version of our system. But the difference is that we use another source of energy, or we use the existing source of energy more efficiently. This was my comment for this question. When we are talking about microwave oven, we need to see where is from electricity. Absolutely.
Yeah, in fact, I think in one of our discussions from long ago, we were even discussing about solar cells, right? Every session that we have, if people say, "Oh, I want sustainability, let me move to solar cells," but if you look at the bigger picture, solar cells, while manufacturing, actually take up a lot of energy. Why? Why does it take a lot of energy to make solar cells? Because these are based out of silicon, okay? And silicon, if you want to make silicon, you have to take it to 3000 degrees Celsius, okay? That's 3000, 3 followed by 3 zeros, degrees Celsius, and which takes up a lot of energy to get all that. So imagine we have farms of solar cells, and all of these have to be made, which means each of those blocks were taken to 3000 degrees C or beyond. Now, where are you getting energy to make those solar cells, right? So yes, of course, you will be making out of non-fossil fuels eventually, but to get to that, we need to spend energy and make these solar cells. That is the first part. Then the next part is, of course, the efficiency of the solar cells themselves and how efficient they are compared to, say, a regular other forms of energy. So we need a bigger sort of purview or a zoom out view. So that's what I appreciate about this question, is that you're not looking at only the function of a very specific system, the microwave, but you've actually zoomed out and said, hey, where is the energy coming from? So it's always helps us to look at the bigger picture, open our minds up. Again, the same point that I raised early on, which is, can we look at the system operator as in from the time perspective as well as the spatial perspective. So time perspective is how was it done in the past, and how whenever you can keep going backwards in time to find out what was the function, how was it satisfied in the past, what were its components, where was it used. So this is one of the things that we normally do. And then look at it in space as well. So look at you can look at the components of the system as well as where was it used, where is it, who needs this output. So looking at it from that perspective as well. So that gives us a broader picture of what's going on.
Yeah, thank you, Bala, for this comment. This comes back to the question of life cycle. We have to be capable to manage calculation of entire life cycle of our product, from the beginning, from the conception to the retirement, and we have to be capable to make this kind of estimation. because the solar cell by themselves, this is a wonderful technology, which can be very well applied, for instance, in countries like United States, where they have a lot of empty space, which with very high sun radiation and very hot temperature, or like in the desert of Sahara. But the solar cells, they are not so efficient in a European condition when we have not so much sun and we have a highly populated territory, where some countries, they use the cropland in order to put solar cell. As a result, we received the rise of the prices for the basic food, like milk and other things. You know, everything, all the question for within a technology forecasting and within a strategic forecasting, they have to be answered in a particular place, in a particular time, for the particular technology. So thank you very much, Bala, for the comments. And now I'd like just to illustrate what I told about just few minutes ago about forecast. Can you see my screen?
Yes, we can.
Okay, this is something that I took from the book of Mr. Modi's and from the original report about forecast for 50 years about primary energy substitution. The wavy curve, those are the data, and the thin lines, those are the forecasts we use in logistic substitution model. And the data point here, for instance, those are the deviation from the model, but you can see that even we have some deviation about oil, after that, the system comes back to what was predicted. Or we had some deviation about coal, but if I look to the dynamics of application of nuclear power and how many nuclear power stations China is going to implement in coming future, 150 new nuclear power stations they are going to put into operation in coming future, it showed me that we will really back about coal to what was predicted for 2020 and 2023. 2020 to 2030, we will be back to what was predicted. And this is about nuclear in the worldwide. What is interesting to see that this is an updated version of the same diagram, but with the data from 2019. We can see that some trends about natural gas, they deviate from what was predicted. Okay, and but this is still the question how we will see in the future. What we can learn from this example of forecast about basic technologies, energy substitution, which was published in 1987, that our technology logistic substitution model is quite reliable model for technology forecasting, even for so long period of time. And in this report, I would like just to emphasize that the same analysis was performed by different countries. And of course, for different countries, it's absolutely not the same as a worldwide. We don't need to make, broad conclusion when just look into the worldwide trends for our particular country. And this is something that I would like to repeat and underline. When we forecast, it's always the question when and where and what. These three questions, they have to be taken all together. So on this diagram, you can see the clock speed of technologies, you can see how they are growing and what is going to change. Now I'd like, if I don't see any comments in chat or no hand rising, I'd like to answer the question that I received. This is a technical one. Could you give us the link to the video about system and set? I don't know why it was repeated. To my mind, we already did it. I'd like just to copy paste it into the chat Okay, once again, I do recommend you to go and to see this video yourself. And of course, if you do appreciate, you can watch other videos from systems and systems innovation. This is the institution that provide interesting training courses about system thinking, which are really useful if you would like to practice forecasting in coming future. I didn't find any other questions in the section of questions about our course. Did you find something more, Bala?
No, not really. I think we're finished all the responding to the questions, so the ones that came on the forum as well as from the ones on the feedback form also. We've addressed them. So good timing as well. We have about 3 or 4 minutes remaining, so we wrapped it in a nice little bow. I feel that we can learn this as a this course as a something to be aware of. What are the techniques? What are the models? What are the examples? All that is well and good. For me, that was great to begin with. But however, we would strongly recommend that you take any technology, any problem that you're working on, and apply this. I mean, I think this is the 25th time I'm saying this, but nevertheless, I will. This is our job to remind you of that. That's primary job, primary function. To put it in Dimitri's words, our primary function is to remind you what works, what are the best practices that we have used to learn this, apply this, see it work for yourself, and the questions and all that, whatever you have, please let us know. Any resources you need, please let us know. Of course, this is also a good time to advertise, or no, not advertise, talk about the 2 things that I have in mind. We have just 2 more minutes, so 2 more things. One is the exam. So for that, for people who are taking the exam, which I strongly recommend, that will really test how much you've learned. There will be application case studies and all that of all the content that we have. So that's one. So for that, we have a live session on 4th of March around the same time, 2:30 p.m. India time. So that's one announcement. And the second one is regarding what I just talked about, is the application. Professor Dimitri, me and Siddharth, who's also on the call, would like to invite you to apply for this workshop on technology forecasting. So you will have hands-on experience on applying technology forecasting yourself, and we will be there to help you, guide you, and share our experiences as well. So that's happening in June. The exam is March, I believe, March some date. So let me just check and let you.
Yeah, meanwhile, when Bala is checking, I'd like just to share with you something that I believe will be useful for you. There are hundreds of articles about logistic S-curve application for reliable forecasting. I just selected out of them 3. Okay, the one is that I shared the result about prediction for 50 years for energy substitution. It works for any country, not only for worldwide. And this is a regional publication, The Dynamics of Energy System. The second one, this is a not so long article, which helps you to understand the mathematics behind logistic growth and substitution. Okay, this you can find in this journal, or you can try to find it in the internet. And the third article, which is a very interesting article to my mind, even it is not so well known. This is an application of logistic curve to analyze dynamics of human empires. And for me, it was very interesting. It was published in the International Journal of Anthropology. And this is, you can see, more than 60 pages document, which analyze more than 14 different civilizations, which evolved according to observed history. And this is very, very interesting also to see that it works not only for technologies, but for social systems as well. And as Bala already told, that the practice, please practice what we suggest for you, because the ultimate test of forecaster, it is a reliable forecast. You know, we suggest you some method, but if you will make your forecast with this method reliable, this is exactly what is the main idea of our course. Thank you very much.
Yeah,
I suppose we can close today's session.
Yeah, so thank you so much, Professor Dimitri and Siddharth, for being there for this session. Thank you so much, the participants on Zoom, as well as people who have been watching it on YouTube, as well as people who will watch the recorded session, this one. So we have those exam dates there. Finally, I figured it out. March 27th, 2022 is when the day exam is going to be. So we'll have our session on March 4th to help you with that. And the tentative dates for the workshop is June 13th to 16th, 2022 as well. So this is these are all the dates. Too many dates to remember, but we'll keep posting again and again, so you can keep your memory refreshed. So hope to see you all in the next session on 4th, as well as we'd invite you to the workshop. Thank you so much, folks. Have a good evening. Have a good morning wherever you are. Thank you so much.
Yeah, have a good continuation. Thank you very much for participating. Bye-bye.
Bye, everyone.